Hello everyone, welcome to Computational Methods in Engineering class. I am RAKESH, Assistant Professor in Mechanical Engineering Department. In this session, I am going to explain one problem on steepest descent method. Let us see the problem. Use steepest descent method for f of x1 comma x2 equal to x1 minus x2 plus 2x1 square plus 2x1 x2 plus x2 square starting from the point x1 equals 0 comma 0. Here steepest descent method means to calculate the minimum point for the given function. Now calculate the gradient of f. First, you can calculate the gradient of f is the gradient of f is that is delta f equal to dou f by dou x1 dou f by dou x2. Now calculate dou f by dou x1. That means partial derivative with x1. The answer is x1 partial derivative, that is 1 minus x2 0, 2x1 square, that is 4x1, 2x1 x2, that is plus 2x2, x2 square partial derivative with respect to x1, that is 0. Similarly, partial derivative with respect to x2, that is x1 0 minus x2, that is minus 1, 2x1 square, that is 0, 2x1 x2, that is 2x1 plus 2x1, x2 square partial derivative with respect to x2, that is 2x2 plus 2x2. Next, you can calculate Hessian matrix. Hessian matrix is, we know the formula for Hessian matrix, that is H equal to dou square f by dou x1 square, dou square f by dou x1 dou x2, dou square f by dou x2 dou x1, dou square f by dou x2 square. This is the square matrix. Okay, now calculate this individual terms. Dou square f by dou x1 square equal to, you can write also dou by dou x1 of dou f by dou x1. We know the dou f by dou x1 value, that is 1 plus 4x1 plus 2x2. Again, partial derivative with respect to x1, that is 1 0, 4x1, that is 4, 2x2 is 0. That means 0 plus 4 plus 0. The answer is 4. Next one is dou square f by dou x1 dou x2. You can also write dou by dou x1 of dou f by dou x2. That is, we know the dou f by dou x2 value, that is minus 1 plus 2x1 plus 2x2. Now again partial derivative with respect to x1, that is minus 1 0 plus 2x1, that is 2, 2x2 0. 0 plus 2 plus 0, that is 2. S- Next term is dou square f by dou x2 dou x1. You can also write dou by dou x2 of dou f by dou x1. We know the value for dou f by dou x1, that is 1 plus 4x1 plus 2x2. Now again, partial derivative with respect to x2, that is 1 0, 4x1, that is 0, 2x2, that is 2. So 1 plus 0 plus 0 plus 2. The answer is 2. Next one is dou square f by dou x2 square. You can also write dou by dou x2 of dou f by dou x2. Dou f by dou x2 equal to minus 1 plus 2x1 plus 2x2. You can again partial derivative with respect to x2, that is minus 1 0, 2x1 0, 2x2 is 2. Okay, now write the values in the Hessian matrix, that is dou square f by dou x1 square, that is 4. Dou square f by dou x1 dou x2 is 2. Dou square f by dou x2 dou x1, that is 2. Dou square f by dou x2 square, that is also 2. This is the Hessian matrix. Let us move to the iteration 1. Iteration 1. In this step 1, to find the search direction at x1, find find the search direction s1 at x1. X1 means initial point, that is 0 comma 0. So now calculate s1 equal to minus delta f of x1. Now we know the delta f values, that is 1 plus 4x1 plus 2x2 minus 1 plus 2x1 plus 2x2. Now substitute the initial value, that is x1 equal to 0 comma 0. That means x1 0 and x2 also 0, minus the values are 1 plus 4 into 0 plus 2 into 0. The answer is 1. Next one is minus 1 plus 2 into 0 plus 2 into 0. That is minus 1. Now change the signs. That is minus 1 plus 1. Next, step 2. In step 2, you can calculate the lambda 1. Compute lambda 1 at x1. We know the formula for lambda 1, that is S1 transpose S1 by S1 transpose H S1. S1 transpose is minus 1 plus 1. S1 is minus 1 plus 1 by S1 transpose, that is minus 1 plus 1. Hessian matrix, that is 4 2 2 2. S1 S1 is minus 1 plus 1. Now simplify this one. You can multiply these two matrix vectors, that is minus 1 into minus 1 plus 1 plus 1. My 1 into 1, that is 1 by first you can multiply these two matrices. Next, minus 1 into 4 minus 4, 1 into 2, that is plus 2. Next one is minus 1 into 2 minus 2, 1 into 2 2, that is plus 2. Write the remaining vector matrix minus 1 1. Now simplify this term, that is 2 by, that is minus 4 plus 2 minus 2, minus 2 into minus 1, that is minus 2. This is 0. Finally we get 2 by 2 equal to 1. You can simplify these terms. You can get 2 by 2 equal to 1. Okay, hence the new point is, next calculate the new point. Hence the new point is new point is means a capital X2 equal to capital X1 plus lambda 1 into S1. We know the X1 is, that is 0 0, lambda 1 is 1, S1 value is minus 1 plus 1. This answer is minus 1 plus 1. Next move to the step 3. Step 3 means check the optimum value. Check the optimum value. That means delta, that means f of x2, delta f of x2. Now substitute the x2 values in the delta f. We get minus 1 plus 1, that is not equal to 0 0. You can substitute these x2 values in the previous delta fx. That means 1 plus 4x1 plus 2x2. That means 1 plus 4 into minus 1 plus 2 into 1. Second one, minus 1 plus 2 into minus 1 plus 2 into 1. These values are not equal to 0. So x2 is not optimum. So this x2 value is not optimum. So move to the next iteration, iteration number 2. Iteration number 2. Here also step 1. Step 1 is calculate the search direction, that is S2 at x2. We know the x2, that is minus 1 plus 1. S2 equal to minus delta f of x2. Similarly, you can substitute these x2 values in the delta f of x2, that is minus of 1 plus 4 into minus 1 plus 2 into 1 minus 1 plus 2 into minus 1 plus 2 into 1. This value is 1 1. Step 2 is calculate lambda 2 value. Step 2 is calculate lambda 2. Lambda 2 means we know the formula for lambda 2, that is S2 transpose S2 by S2 transpose H S2. S2 transpose is 1 1. S2 is 1 1 by 1 1. Hessian matrix is 4 2 2 2. S2 is 1 1. Now simplify this one, you can get 2 by 10, that is 1 by 5. Hence the new point is new point is new point means that is x3 equal to x2 plus lambda 2 s2. uh, Now substitute the values here. x2 value is minus 1 plus 1, lambda 2 is 1 by 5, s2 is 1 1. Now simplify this one, you can get minus 1 plus 1 by 5 into 1, that is minus 0.8. 1 plus 1 by 5 into 1, that is 1.2. This is the new value. Next, step 3, check the optimum value. Step 3, check the optimum value, that is delta f of x3 equal to now substitute this x3 y3 values in the delta f. We get 0.2 minus 0.2. These values are not equal to 0, so x3 is not optimum. Let us move to the iteration 3. Iteration 3. In this also, step 1. Step 1 means you can calculate the search direction S3 at x3 that is S3 equal to minus delta f of x3 equal to this x3 means minus 0.8 and 1.2. These two values substitute in delta f, you can get delta f of x3. That value is minus 0.2. Next, step 2. Step 2 is calculate lambda 3. Lambda 3 equal to S3 transpose S3 by S3 transpose H S3. Now substitute the matrices here. S3 transpose, that is minus 0.2, 0.2. S3 is minus 0.2, 0.2 by S3 transpose, that is minus 0.2, 0.2. Hessian matrix is, that is 4 2 2 2, 4 2 2 2. S3 is minus 0.3, 0.3. Now simplify this matrices, we get 1. Hence the new point is x4 equal to x3 plus lambda 3 s3. Now substitute the values here. X3 is minus 0.8, 1.2. Lambda 2 value is 1. S3 value is minus 0.2 plus 0.2. Now simplify this one, we get minus 1.0, 1.4. Next, calculate delta f of x4. Step 3 is delta f of x4. Now substitute this x4 y4 in the delta f equation, we get minus 0.2, minus 0.2. These values are not equal to 0. So x4 is not optimum. So move to the next iteration, that is iteration number 4. Iteration 4. Here also calculate step 1, that is S4 equal to minus delta f of x4 delta f of x4 means you can substitute x4 and y4 values in the delta f equation. The values are 0.2, 0.2. Step 2 is now calculate lambda 4. Lambda 4 equal to S4 transpose S4 by S4 transpose H S4. Now substitute the values. S4 transpose is 0.2, 0.2 into 0.2, 0.2 by S4 transpose, that is 0.2, 0.2. Hessian matrix 4 2 2 2 S4, that is 0.2, 0.2. Now simplify this term. uh, you can get the value is 1 by 5. Hence the new point is that is x5 equal to x4 plus lambda 4 s4. X now substitute the values. X4 is minus 1.0, 1.4, lambda 4 value is 1 by 5, s4 value is 0.2, 0.2, this value is minus 0.96, 1.44. Step 3. Calculate the optimum value at x5. That is delta f of x5 equal to, now substitute these x5 y5 values in the delta f equation. We get 0.04 minus 0.04. These values are approximately equal to 0, 0. So x5 is optimum. X5 equal to minus 0.96, 1.44. That value is the uh, minimum point for the given function, that is x1 minus x2 plus 2x1 square plus 2x1 x2 plus x2 square. I hope this is very clear to everyone. Thank you for watching. Please do like and subscribe my channel for more updates.